Let's talk chemistry with Pastor Dan. Sorry about the voice being a little bit raspy. Been trying to fight off a slight cold or asthma or something. All right, so let's get started here. We're going to take a concept now and put everything for the last couple of sections together. We're going to do chemical reactions. We're going to do moles. We're going to do molar volume, molar mass, and we're going to look at balancing equations, all those things into one process called stoichiometry or stoichiometry, depends how you want to say it. Definition of stoichiometry, process determining the substance in a chemical reaction based on molar relationships. Now, there are two types of stoichiometry. The first one we'll look at today is called mass stoichiometry. So we're going to deal with masses. Now, there are specific steps we're going to go through to do this. So the first thing we always want to do is write the balance equation, okay? So write the equation, get it balanced. Put the given over 1, like we always do to start the information. We're going to convert to moles. Now, why do we convert to moles? Because moles are units of chemical reactions, so therefore we need to make sure that we're in similar units, so moles is what we use. We're then going to convert to the desired substance. We're going to go from something to something. So because of that change, we need to convert and find the relationship between those two, and then divide the converted units, desired units. We're going to start with mass here, but eventually we'll include volume as well. We could do atoms or molecules, but that almost doesn't seem necessary all the time. All right, so let's get started with the problem. Here we go. For the reaction, CuCl3 plus K yields KCl plus Cu, or copper 3 chloride plus potassium yields potassium chloride plus copper. Determine the mass of potassium chloride formed if 57.98 grams of potassium react with excess copper 3 chloride. All right, so we have the reactions. We don't have to write it. We have to balance it, though. So balance it up. My coppers are good. Potassiums are good. Chlorine's not so much. So we're going to put a 3 and a 3, and that's balanced. Now, the second step, put the given over 1. So my only given information right here is 57.98 grams of potassium. So I'm going to put that over 1. Now, in order to use a chemical reaction, we have to be in moles. So looking back at the periodic chart again, we're going to find that the atomic mass of potassium is 39 grams. Remember, we round the whole numbers in here just to make it easier. There is a decimal, that's due to abundance. We talked about that before. Now, what two substances are we on? There's only two we're concerned with. In this problem, I'm in potassium, and I'm asking for potassium chloride. So it's these two. These are the only two I care about. Copper 3 chloride and copper can go away. They don't matter right now for this problem. So what's the relationship here? From the balance equation, 3 moles of potassium is 3 moles of potassium chloride. So we want to set it up so potassium crosses out. So potassium has to go on the bottom. Potassium chloride goes on top. So 3 moles of potassium chloride over 3 moles of potassium. And then lastly, we want the desired units. That's mass. Mass, in order to define a compound's mass, we have to do formula mass. So we have 39 for potassium, 35.5 for chlorine, and about 74.5 grams of potassium chloride is 1 mole. So we want to get out of moles and into grams. Moles go on the bottom. So just check to make sure. Grams cross out, moles cross out, potassium chloride cross out. We're in the desired units we want. Take and multiply cross. 57.98 times 3 times 74.5 equal divide by 39 equal divide by 3. Or if you see that, you could cross these out and just make it this times this equal divide by 39. And when we do that, sig figs, well, this is infinite, this is infinite, this is infinite. This one we have 4, so we have to have 4 sig figs. Answer is 110.8 grams potassium chloride. That's my answer. All right, let's try another one. Okay, so this one I'm not going to give the reaction, but we're going to keep it pretty simple right now just so we don't freak out. Find the mass of nitrogen. Need to completely react with 45.988 grams of zinc. Now, see, this is where we're telling you, you could go anywhere in the reaction we want. We can go reactant to reactant, reactant to product, product to reactant, product to product. It doesn't matter as long as it's in the reaction. All right, so let's start with our reaction. We have nitrogen and zinc. Remember, nitrogen is diatomic, so it has to be N2. Now, what kind of reaction is this? If I have 5 types, chemical reactions, starting with elements, that's going to be synthesis. Now, we have to remember, Pastor Dan's the devil, no. Oxidation numbers, zinc's +2, nitride, not nitrate, is -3. So cross them down, we get ZN3, N2. Balance it up, put a 3 there for zinc, and we're good to go. All right, what's my given information? What says 45.98 grams of zinc. To put that over 1, there we go. And we want to get from zinc into the reaction, we have to use molar relationship. The periodic chart, 1 mole of zinc is 65 grams. Now, which two are we interested in? We're only interested in zinc and nitrogen. Zinc nitride, I'm not concerned with. So what's the molar relationship here? 3 moles of zinc is equal to 1 mole of N2. So in order to get it crossed out, zinc has to go on the bottom, nitrogen has to go on top. We're going to put 1 mole of N2 over 3 moles of zinc. And I'm asking for mass. So there's 2 atoms in N2. So 2 times 14 is 28 grams of N2 is 1 mole. We want to get rid of moles, so moles go on the bottom, grams go on top. So 28 grams of N2 over 1 mole of N2, multiplied through 45.988 times 28 equal divided by 65 equal divided by 3 equal, again, we have 5 sig figs here. So we end up with 6.6034 grams of nitrogen. That's my answer. Of course, we could have checked everything does cross out. Let's do one more here. Let's do this one. What mass of aluminum is needed to react with oxygen to form 55.98 grams of aluminum oxide? So this time we're going from product to reactant, so we can go either way. All right, so let's get started here. Reaction. What's reacting with what? Looking for the words react with. That always helps. What's reacting with what? Aluminum. Reacting with oxygen. Remember, oxygen is diatomic. Again, 5 types. We're keeping it simple. Still synthesis. So we're going to generate aluminum and oxygen. But we have to remember oxidation numbers. Oxidation aluminum is 3. Oxygen's -2. Cross them down. Al2. Whoa, what is that? All right. Al2O3, balance it up. We're going to put a 2 there. Oxygen's 2 and 3. So put a 2 and 3 and 2. Now I have 4, so I got to change aluminum to 4. There we go. Put our given over 1. So we have 55.98 grams Al2O3 over 1. Now, that's a compound. Compound needs formula mass. So we have aluminum oxygen. I have 2 and I have 3. Atomic masses, aluminum is 27, oxygen 16. 2 times 27, 54 grams. 3 times 16, 48 grams. Add them up. I get 102 grams Al2O3 is 1 mole. Al2O3, I'm going to get rid of it, so the grams have to go on bottom. Moles have to go on top. So 1 mole Al2O3 over 102 grams Al2O3. Now, molar relationship, we're only interested in aluminum and aluminum oxide. So molar relationship there is 4 moles of Al is 2 moles of Al2O3. So again, Al2 we're going to get rid of on the bottom, aluminum on top. So 4 moles of aluminum is 2 moles of aluminum oxide. Periodic chart again. Aluminum right over there. 27 grams is 1 mole of aluminum. So my grams of aluminum oxide cross out, moles of aluminum oxide cross out, moles of aluminum cross out. Or in grams, multiply through 55.98 times 4 times 27 equal divide by 102 equal divide by 2. Or you can see this relationship here. 4 divided by 2 would be 2. So we could do 55.98 times 2 times 27 equal divide by 102 equal 4 sig figs. We get 29.64 grams aluminum. Hopefully that's not too bad. Let's try a couple for you to do on your own. So here's 2. Do these on your own. First one, we're going to keep it simple still. Synthesis. Find the mass of zinc needed to react with chlorine. Remember, chlorine is diatomic to form 81.225 grams of zinc chloride. And the second one, what is the mass of barium carbonate needed to react with 18.11 grams silver nitrate in the reaction? AG, so I gave it to you there. So stop the video, work on this, see what we come up with, and once we're done, start it back up again, and we'll look at it, okay? Okay? All right, here we go. So, for the first one, my reaction is Zn plus Cl2 is ZnCl2. It's already balanced, and these are the two I'm interested in. We're going to take 81.255 grams of ZnCl2 from the balance. If zinc is 65, chlorine 35.5 is 71. 71 plus 65 is 136 grams. 1 mole is 1 mole, and zinc 65. We get 38.835 grams of zinc. For the second, we have to balance a reaction first. So put a 2 in front of the AgNO3. I'm interested in these two, silver nitrate and barium carbonate. Now, put the given over 1. Formula mass, silver 108, nitrogen 14. 16 times 3 is 48. 48, 14, 108 is 170 grams is 1 mole. Now, that's always for 1 mole. We don't worry about the 2 here. That gets taken in the next step. So we put that under 1 mole. The balance equation, 2 moles is 1 mole. So therefore, there we go. And then barium 137, carbon 12, oxygen 16 times 3, 48, 48, 12, and 137 is 197 grams. Cross out our units, get our final answer, 10.49 grams barium carbonate. Hopefully that wasn't too bad. We will practice these on, where we have the schedule here. We're going to do a lab tomorrow. Then we'll practice these the day after that and work through them. Hopefully that wasn't too bad. Take care. God bless. Have a good day.